Now let's discuss about double pointer. So you have seen till now we can declare a pointer which can hold the variable of another, which can hold the address of another variable, alright. But if you want to store the address of a pointer itself, how you can do that? So C programming gives us the facility to use double pointer. So this double pointer is a variable which will hold the address of another pointer basically. Okay, I will explain this with an example. Let's say if I have declared, one variable integer x which is having value 100. Okay, now if I declared a pointer ptr which is going to hold the address of my x variable actually, right? Or maybe I will give the name p only. Okay, then now I want to hold the address of this pointer itself. So as I said, we need to use double pointer here. So how to declare a double pointer first? So to declare the double pointer, we have to add one more star operator here basically. All right, so the way we were initializing single pointer by using single star, this double pointer will be allocated using this double star basically. So double star means double pointer. All right, so now how we can initialize the value of this double pointer, basically how to give the address of this pointer to this double pointer. All right, so the way we were using address operator to give the address of any variable, the same way we'll use the address operator here, and we'll use the address operator with the pointer itself. So here the pointer is p. All right, so this will give the address to your double pointer. All right, so to understand from the memory visualization point of view, if you can see here, I have declared one pp pointer which is double pointer. So let's say now the address of this pp in memory is, let's say, 4000. Okay, and this pointer p is stored at, let's say, some address 2000, and this is, let's say, stored at the address 1000. All right, so now pp is holding the address of p, which means pp will have value 2000 stored in it. All right, p is holding the address of this x variable, and the address of x is 1000, so p will hold value x 1000 in it. All right, now how to dereference a double pointer? So let's say if I want to get the value of x using this single pointer, I can simply dereference p, I can get the value of integer x. But how to dereference a double pointer so that I can get the value stored in it basically? So I can use this value operator, value add operator basically, with this double pointer also. So if I will write pp here, so what it will give, it will give me the value stored at address, right? That is the meaning of your value pointer, value at pointer basically. So now the address stored in pp is 2000, right? So sorry, the address of pp is 2000. Sorry, my mistake. So the address stored in pp is 2000, and the value at 2000 is 1000, right? So now star pp, when I will write, so it will give me 0x 1000. All right, now if I will use double star on this, then what it will give, because first star gave me the value 0x1000. Now again, if I will use star, it will give me the value at this particular address, and the value at this particular address 1000 is my x variable actually. So it will give me x as an output. So which means if I will use dereference operator, single dereference operator with this double pointer, it will give me the address of pointer p, which is single pointer. If I will do double dereference on it, so it will go one more step ahead, and it will give me the value of this integer x. All right, so by using this double pointer, interviewer can ask a lot of question basically, because I have seen people get worried when they see lot of double pointers or triple pointer question in the interviews, because interviewer can increase the complexity of this kind of question by increasing the double pointer to triple pointer. For example, here we were declaring double pointer like this ptr, right? he can also increase like he can also ask you question about triple pointer. So what does triple pointer will do now? So triple pointer, let's say if you have declared ppp, so now ppp will hold the address of your double pointer actually. All right, so don't basically get worried whenever somebody will ask you question about double pointer, triple pointer. So instead of that, just break this question into the simple steps of pointer. Let's say from a triple pointer to double pointer, and then from double pointer to the single pointer, and then single pointer to value. So if you will break down your question in that way, so it will be easy for you to solve these kind of questions. All right, so now let's talk about when to use double pointer. Maybe we can basically use this double pointer to write some examples to understand this better. So generally wherever in your project or in your program you want to modify the value of pointer basically, or you want to pass the address of pointer itself to some other function, so there also you want to use double pointer, right? If you want to pass the address of pointer itself as an argument to a function, so you need to use double pointer there. For example, we'll write a program to understand this. Okay, let's say if I am writing a program here. So I have declared a pointer here and initialize this pointer with null. Okay, I'm calling a function allocate. So what does this allocate is doing basically? So right now my ptr is not pointing to anything, so it is pointing to null. But what I want is I want to allocate a memory of one integer, and I want to give address of that memory to this pointer variable. Okay, but I want to allocate this memory not in this function actually. I want to allocate this memory in another function which I will call. Okay, so what will happen in that case? So now what I want is I want this ptr value to be changed, even though I'm passing this as an argument to the function, but I want to change the value of this ptr. So if you want to see the value update in another function, so definitely you have to pass this argument as a basically pointer, right? Then only if you will make any change into the called function, you will see the effect in the caller function as well, right? So here that is why I am basically passing the pointer or address of this pointer basically here in this allocate function. Now let's write allocate function, what this allocate function is doing. So let's say this is my allocate function. So as I said, it will take address of pointer, so obviously it will be double pointer. Let's say double pointer star pp. All right, so now as I said, we need to allocate some memory of an integer. So how we will allocate the memory of integer? By using malloc, and then we'll give size of integer, right? So when we allocate memory using size of integer, it is going to return as void pointer, but because we want to allocate this memory for an integer, so we can typecast it to integer star. All right, so this memory allocation is returning now integer star, which is the pointer to an integer, right? So we can store this at this value basically, value or address basically. We can store this address of this newly allocated memory into a pointer, right? So as I said, we need to store this address into this pointer. How we can use that? So if you see, we have received the address of pointer here. All right, so if I will use dereference on this pp, okay, dereference of pp. So dereference of pp means ptr basically, so it will change the value of ptr here, right? So now the ptr is assigned with this newly allocated memory. All right, now because now some memory is basically allocated and ptr is pointing to that memory. Now if I want to access that memory, or if I want to assign some value to that memory, how I can do that? Simply if I will write star ptr equals to 10, so this way I can do it, right? So just to summarize here is, whenever you want to uh, update the pointer itself into the called function basically, there you can use the double pointer, right? And other way, sometime you will see, if you want to allocate some two-dimensional array where you are not sure about the number of rows and column when you are basically declaring that array. So there also you can use double pointer to basically create a two-dimensional array. I have seen people asking these questions in many interviews, like they will give you the double pointer and they will ask, make a 2D array out of it. Okay, and the number of rows and column will be decided at runtime. All right, so wherever you will face this kind of scenario where you will be getting this number of rows and column at runtime, so what you need to do here is, there you can use two-dimensional array to basically create, sorry, there you can use 2D pointer to, sorry, double pointer to create a two-dimensional array. All right, for example, let's say if you want to create a matrix basically, because this it's a 2D matrix. Okay, so now let's say integer star star matrix, and this matrix 2D array has to be of size, let's say, column and row. So this rows and column will be decided at runtime. So when I get the value of rows and column, I will be starting my procedure to basically create a two-dimensional array. All right, so how I can do that? You can just assume your two-dimensional array like this. So this is your two-dimensional array. Okay, just to make this example simple, I am assuming I am creating a two-dimensional array of size 3 cross 3. It means the value of row is 3 and the value of column is also 3. All right, so I can break this 2D array into three single dimensional array actually. So this will behave like my first single dimensional array, this will behave like my second single dimensional array, this will behave like third single dimensional array. All right, so now if you know this array, name of array basically, so name of array generally behave like a address of your first value of the array basically, or we can say the base pointer or base address of this 1D array basically. All right, so first you need to have a double pointer which will store these three single pointer value basically. All right, now you need a double pointer which is going to store three pointers or address of three pointers of type integer. All right, so what you can do here is, you can allocate the memory of three pointers basically. First pointer will be storing the address of this one dimensional array, second pointer will store the address of this single dimensional array, and then third pointer will store the address of this third single dimensional array. All right, so I'm allocating memory for three pointer here. So what I'm doing here is matrix, and then I'm doing malloc, okay, 3 into size of integer star. Please note it here, I am allocating size of integer star. Obviously it will be equal to the size of integer on 32-bit machine, but still I am giving the size integer star here. And then after allocating the memory of integer star, it is like malloc is going to return double pointer to me, right, which I will typecast it to integer star star. All right, so now matrix is holding the address, so matrix pointer which is double pointer, so double pointer is holding the address of these three pointers basically. Okay, so what does it mean? It means, let's say now you have received three pointers basically. Okay, three pointers, so memory for three pointers allocated. So as you know, like mem pointer is going to store the value of another variable, right, the value of another variable. Now by using this I need to create a row here, here also I need to create a row, here also I need to create a row. So this row will behave like a single one dimensional array. All right, and the address of this row, basically the base address of this row, or the address of the first variable of this row will get stored in this, and the similar way address of this first variable will stored here, address of this row first variable will stored here. All right, now how to proceed further to create this 2D array, right? So what you need to do here is you have allocated 3 pointer memory. So now in the next line what you have to do is you have to allocate for integer I equals to 0. I will go till your rows basically, because number of rows will be equal to your number of single dimensional array, right? So it will be equal to row, and then what you will do, you will do I plus plus, and then for each row you need to allocate, because in each row there will be columns, so number of columns value basically, let's say for in this example it's 3, so you are going to store 3 integer in a single row, right? So you need to allocate the memory for 3 integer variable, right? So here you will be allocating memory for 3 variable. So if you will write matrix I, so what is matrix I? If you remember, we have, or in the array chapter we'll discuss, once you write array I, so what does it mean? It means array then I and then value add operator there, right? So here when I am doing this, so matrix I will give me the value of this first ptr actually. Okay, so I am assigning the 3 integer value, and the base address of that 3 integer I am assigning to this matrix 0, and then matrix 1, and then matrix 2. Okay, so what you need to do here is integer star, because this is my integer star, so I need to typecast it the integer star, and then I will give here malloc, and then here I will write 3 into size of 3. Why I am using 3 here is because column size is 3. If you are not sure about what is the size here, you have to just give column here, because column will was assigned to some value, right? So you just give column here and then size of integer. So here we allocated size of integer star, but here you need to allocate the size of integer, because now you are going to store the actual integer basically, right? Which will have the values, that is stored in your two-dimensional array, right? So this will basically allocate this columns, basically 3 values per column it will allocate, right? So now matrix is a double pointer, but it is holding the address of your two-dimensional array which you have just created. So if you want to access any variable or any element basically out of this 2D array, you can simply use the way you access other 2D dimensional array matrix, and then write x y. X could be 0 1 2 depending upon your rows, and then column basically, right? So it could be also 0 1 2 3 depending upon your number of columns present into your array. Alright, so this was the use of double pointer to create a two-dimensional array. Now we will see few questions related to double pointer. Basically these kind of questions asked in the interview, so let's discuss these questions so that we'll have clear understanding of double pointer. So in this example, if you see, I have declared a variable x, and then b is holding the address of x, and then double pointer I have declared which is holding the address of p. So this is just like the example which we just discussed actually. So if you will use star star pp, it means you are dereferencing double pointer actually, and you are using 2 star. So first star will give you the address of x, and another star will give you the value 10. So output of this program will be 10. All right. Now in the next question, what you are doing here is you are creating an integer variable. The value of integer variable you are assigned 5, and then you are giving the address of this integer to this integer pointer actually, and in the next line you are again creating a double pointer which will hold the address of this pointer p, and you are again doing like this double dereferencing. So when you will do double dereferencing on any double pointer, so definitely it will give you the value this. So this value is 5, so 5 plus 5 will be 10. So output of this program will be 10. All right. So here this is the tricky question actually. If you see here is you have created a double pointer. Okay, you have created the double pointer which is uninitialized. All right, now you have created a variable x. Okay, and the value of x is 20. So here what you are doing is you are allocating, sorry, you are initializing this double pointer with address of x. But when you just use single dereferencing operator on this double pointer, so what does it will point to, right? So it will be, if you see here is this pp is uninitialized, right? So you cannot dereferencing it. A variable, or if, sorry, a pointer variable which is not yet initialized, you cannot dereference it, right? How you can get the value of from that address if the address itself is not there, right? So it will be undefined behavior. It can even lead to the crash in your system, right? If you want to fix this issue, you can have some intermediate pointer, let's say star p, which is holding the address of this x, and then star pp is assigned with this p instead of this x basically. So this will solve your problem. All right, so let's move to question number 4. So here what you're doing is, this is also again the same example which we have discussed. So you are creating a pointer of integer type, you are calling a function allocate, and in that allocate function you are passing the address of this pointer p, sorry, a pointer p. Okay, so because you are passing this as pointer p, so this is being captured in the double pointer, and in this dereferencing of this double pointer you are allocating the memory of integer. So it means you have allocated memory integer. Okay, so integer size memory you have allocated here, and this memory is pointed out by this star pp. So star pp is nothing but your p. All right, so now p is pointing to this initialized or allocated memory basically, and then you are doing double star star p. So when you will do star star p, it means p is holding the address of this memory, and on that memory some variable value will get stored. So this star star p will be storing 42 here. All right, so once you will come out of this allocate, you will be printing star p. So you see now you are dereferencing this pointer here. So p is uh, so dereferencing means it will give you the value at that particular address. So p is holding the address of this memory which you have just allocated. So the value at that particular address is 42. So the output of this program will be 42. All right, let's move to the next question. So here you have declared one pointer, and then you are calling function pointer and passing the address of this pointer which is being like collected here in double pointer, and then you are doing same thing, you are doing star p and malloc size of integer, you are doing it here, and then star star p assigning this value with 10. Okay, so same thing which we have done in question number 4, the same thing we are doing it here, only the name of function is changed. So the output here will be 10. All right, okay, this is array based question. So you will see a lot of question in the interviews which will have combination of arrays as well as pointer. So in most of the chapter I will be covering this pointer and array questions. Okay, so here you see you have three variable integer a b c, all three are initialized with some value. Okay, and here you just notice it, instead of creating an integer array you are creating an array of pointer here. Okay, what does it means? It means you are creating this array, but earlier when we used to allocate array, we used to store some value, but instead of that it will store some address, let's say 0x 1000, 0x 2000, and 0x 3000. But now as per this assignment, this a is, so the first element of this array is holding the address of a, so I'm assuming the address of a is 1000, address of b is 2000, address of c is 3000. So it is being basically captured or basically pointed out by all these three pointer actually one by one. All right, so when I'm doing percentage d and then dereferencing on the pp, so now pp is basically holding the address, base address basically of this array which you just created, arr, which is like array of pointer, integer pointer basically. All right. So when you will do star star p here, so basically on the very first element it is doing, so you know, like this 1000 is pointing to this value 100, so this will give you 100. And then you are incrementing this pointer. So when you will increment this pointer, which is like pp plus plus, so you know, like pp was pointing to this value, and then if you will increment this, this will move to the second element in this array. All right. So now you are dereferencing it, so you know, like on dereferencing it, you will get the value 200. All right. And then again you are incrementing it to the third element. Okay. And again you are dereferencing it by using the double dereferencing on your double pointer basically. Then again it will give you the value 300. So output of this program will be 100, 200 and 300. Okay. Now this is the allocation of 2D matrix using double pointer. We have just discussed it, we will not discuss it here. You can go through it to understand this program clearly. Okay, so now do you see any issue with this? No issue. So what is the difference between these two declarations? So very first declaration is you are declaring an integer of array of pointer, integer pointer basically, which will hold the address of 5 integer. Okay. In the next line you are declaring a double pointer. All right. So both statements are valid. All right. So do you see any error in this? Let's check it out. You have declared an array of 3 integer, and you have basically created a pointer, and this pointer is basically assigning with the array, base address of this array. Right. And then you are calling a test function with the address of p. So address of p means you are passing the address of this first element of this array, which is 10. So it is collected in your double pointer, and you are dereferencing that double pointer 2 times actually. So obviously it will goes back to the value of p, and then it will goes back to the value of this element of this array. So it will print 10. Okay, so there is no error at all. It will give you the output 10. Okay, so this is the last question of this double pointer discussions. So here you have created a variable x, value assigned is 5. You created another variable p, which is single pointer having the holding the value of x, address of x. Okay, then double pointer which is holding the address of your p pointer, then triple pointer which is holding the address of your double pointer. All right. Now you are doing ppp, so basically triple pointer. So very first dereference will take you to the pp. Second dereference will take you from double p to single p, single pointer basically, and then another pointer will take you to the actual value. So the output of this will be 5, and then you are adding 10 here. Okay, adding 10 here, so it will be 15. And the value you are changing here is again 3 pointer will leads to your x. So now x will have value 15, so 15 will be the output. All right.